You'll have noticed by now that human demography is a pretty dynamic process. It's never static, always moving both in space and time. And I think that's a really interesting thing. Now, in order to describe those movements through space and time, there's a part of demographic science called demographic transition models. And this is a field of study that attempts to describe human societies and their populations as they move through time and as they develop at different rates and for different reasons. I don't want to be prejudicial. I don't want to say evolve through time, because it's not a series of moving from worse to better. It's a series of moving from one step to the next. And different countries do it in different ways. And it's not even about countries. Sometimes it's about regions. And so I think as we go in and start looking at these demographic transition models, just remember that they're models. They're ideas and ways of thinking about things that aren't necessarily entirely reflective of reality. So the whole idea, and sort of probably the first person to publish on demographic transitions and what was going to happen in the future with dynamic human populations was Thomas Robert Malthus. And you might have heard of Malthusianism. And his idea was that we would grow like cancerous cells, essentially, as humans. We'd grow so quickly that we would use any extra food or resources, and we would grow exponentially as a population, and that our resources would only grow linearly. And if you ever put a linear line over an exponential line, you'll see that the exponential line quickly outgrows any kind of linear growth. And so the idea here is that we would outgrow our resources rapidly, and we'd starve to death. It'd be terrible, horrible. We'd all die. We'd essentially eat ourselves out of house and home. But I want to be very clear that it's become very clear that Malthusianism is not the case. Yes, we did grow rapidly, and one might even say exponentially, for a little bit, but we've clearly reduced that growth, and we're no longer growing exponentially as a human population. And our resources have not just grown linearly, our resources have increased with us. Not exponentially necessarily, but rapidly, and definitely in a non-linear way. So what are some other ways that we can think about demographic transitions? And this is probably one of the most famous ways to think about demographic transitions, but it's also, again, it's just a model, and we've shown that it's not necessarily the right model for a lot of nations today, and technology has a lot to do with that. And the way this works is this big dark line is the total population of a country or a region. This solid green line is the death rate, how quickly people are dying, and this dotted green line is the birth rate, or how quickly people are being born. Now, notice that when the birth rate and the death rate are roughly the same, total population is relatively stable. When the birth rate outpaces the death rate by quite a bit, you get population growth, right? And then here, over here on the right-hand side, where the birth rate is less than the death rate, you get a decrease in population. Now, the person who developed this sort of noticed that it appeared, from a very Western European point of view, that there were stages in the development of different nations. And he named these stages high stationarity, early expanding, late expanding, low stationarity, and declining. 1, 2, 3, 4, 5. And the idea was that in less developed nations, you had a high birth rate, a high death rate, relatively stable population. But the reasons for the changes in the birth rates were lots of children were needed to farming, high infant mortality, religious and social encouragement, no family planning. Many children die due to poor medical knowledge or infrastructure. Okay, so this is sort of the least developed nation. When you begin to increase medical care, improve medical care, water supply, sanitation, and fewer children die, people are still having lots of children, but more of those children are living. So the death rate declines, your birth rate stays the same, and you begin to grow your population, and you get a very rapid natural increase. In this sort of late expanding stage, people begin to realize, oh, you know what? Not all my kids are going to die. Let's just have a few. Um, and you have improved medical care and diet, fewer children needed. It may be that education is becoming there. More people have more access to education, especially with women. There's a strong relationship between population growth and women's access to education, and fewer children die. And then finally, sort of these developed nation models here, where you have low birth rates, low death rates, lots of family planning, good health, access to health care, the improved status of women, marriages later in life, good health care, reliable food supply. And then this other stage here, where you find that eventually, in some cases, nations begin to have fewer children. Parents don't have one children, and so they're not replacing themselves. And so you begin to get this natural decrease in population. Now, it's pretty clear that some nations jump steps. And either that's because of technology, it might be natural resources become available that weren't available before, or become needed that weren't needed before, and it can jump these stages. And that pretty clearly happens in some cases. Japan, Germany would be an interesting, not an interesting, but are a really good example of this stage 5. Is demographic transition inevitable for developing nations? No, is the simple answer. It occurred in European nations, but it may not apply to all developing nations. And it could be that they might place greater religious or social value on childbirth. It could also be that they grant women fewer opportunities outside of child rearing. So a lot of these demographic transition models, interestingly, revolve around the status of women, which I think is interesting. Look, how much of an environmental issue is human population growth? And with respect to demographic transition, if you look at these models and think about how they apply to the world today, there are some interesting places where it appears they apply, especially in Japan, Germany, Russia. Lots of Eastern European nations are going through a population decrease now, but there's still lots of areas in Africa with high rates of population growth. And again, this is due to some of the things I mentioned earlier. So while the models aren't perfect, they do have some interesting facets that help explain why human populations are so dynamic.